Hello everyone, welcome back. In this video, you are going to learn how to construct a truth table. In the last video, I explained that when you have a proposition, that is a statement that can either be true or false. So when you have a statement that can either be true or false, but not both, we call it what? A proposition. So, and when you have such a statement to be true, then the truth value of such statement is true. That is T. We write it as T. Likewise, when you have a proposition to be false, then the truth value of such a proposition is what? Is false, which is also written as F. So, in this video, I'm going to explain how you can construct a truth table. But before I continue, if you are really serious about learning mathematics from scratch, then you have come to a right place. Why not kindly subscribe to my channel so that you see my subsequent video, and possibly click on the bell button so that you get notified anytime I upload new video. Also, please kindly share this video to your friends, colleagues, children so that they can benefit from this too. So I make this video, in English and Yoruba fashion. So then if you are interested in Yoruba fashion, refer to the comment, you will see the link to it. So yeah, before I continue, recall we have two types of statements. We have simple statements. Then we have what? We have compound statement. Compound statement. I told you the difference between the two type of statement is that when you have simple statement, so then simple statement is what? Just the combination of what? Subject and predicate. What is your subject? It can be the noun or your pronoun in the sentence. Someone, the who in that statement. If I say the dog is barking at the cat, so it means the dog in that particular statement is my subject. So, and my predicate, when we say predicate, that is what is the subject doing in that particular statement. That's my what? My predicate. So, but when we are now talking about compound statement, so compound statement is the combination of what? Two or more simple statements. So, but when you now have two or more simple statements now, so those two statements are what? They are joined together by what we call connective or conjunction. Two or more statements. So two or more statements joined by H, joined by connectives. And don't forget, I said your connective, I gave you 5 of them in the last video. You can have your negation, you can have your you can have your conjunction, you can have your disjunction, you can have if then you can have if and only if. So I've defined and I explained all these logical operators or connective. So in what? In the previous video, if you've forgotten, you can what? You can refer to those video. Recall, these are also known as what? They are also known as logical operator. So they are also known as logical operators. I hope you understand now. So they are operators because we have arithmetic operators. When we say arithmetic operator, that is when you are, I mean, combining two numbers together. If you are combining two numbers together, then you have to combine them with a particular operator. You can combine them with operator of addition. In that particular sense, you have 2 plus 2. This in number, this is another number. We join them together with this operator. So then we have addition operation. I hope you understand. Likewise, when you have two statements, or more. What you can use to join them together is what? Is your logical operator, and it can be negation. I hope you understand now. It can be your conjunction, disjunction, and so on. Okay, now how do you now construct a truth table? When we say a truth table, you understand that when I have a statement P, for example, so the dog is barking. Let's say, for example, this is a statement. If this statement is true, irrespective of whether it is true or false, if it is true, then the truth value of this statement is what? Is T. I hope you understand now. So the truth value is T, but if it is false, the truth value is what? Is F. So the truth value is F. So when we now say truth table shows how truth or falsity of a compound statement depends on the truth or falsity of the simple statement. So from which it's corrected, it is constructed from. We know that when I have a statement, it can either be true or false. I hope you understand now. Okay, now what if you now have a compound statement, maybe two statements now, I mean, it can be true or false, it can be true or false. When you now combine them together and you now have the possible combination of true and false, what do you have together? So when you are constructing such a table, that's when we have what? A truth the truth tables, and I'm going to describe it for each of the connective, for each of the logical operators, so that you know perhaps when you have two combination of statements together, if one of them is true and if then one of them is false, if you combine them together, what does it mean? If you use any of the connective, what does it mean? That's what I'm going to do. Okay, now let us just do it one by one. Let us take the connective one by one. The first connective I'm going to take is what? Negation. Let us construct a truth table for negation. For negation, I said mostly we are going to be using negation for what? Maybe a single what? A simple statement. You can apply of all, I mean, the logical operator that is the connective, it is only negation that works with what? A simple statement. You cannot use conjunction and for simple statement because you are not combining it with something. Likewise, you cannot use or, you cannot use if then. So and or if then, if and only if, they are only used for compound statement. You understand now? So but if you want to, what is only applicable, I mean the connective that is only applicable to simple statement is known as negation. So let us do it. The combination of a statement. Let's say I have a statement P. Suppose we have proposition P. When we have a proposition P which can either be true or false, the possible, I mean, what do we call it? The possible truth value we can have is what? Is just true and false. I hope you understand now. So it is just true and false. This is your negation sign. So then we have P. It's just like when you are tossing a coin. When you don't have head, you have tail. Likewise, when you have your P now, then you have your true. It can either be true, it can either be false. Then what is negation? Negation means to negate P. That is, and I explained that when you say negation of a particular proposition is going to be true if that what? If that proposition is false. And the negation is going to be false if that proposition is true. It means when you have a proposition to be true before, then its negation will be false. I hope you understand now. And when you have a negation to be false before, its negation will be true. I hope you understand that that's just negation. If it is true before, then its negation will be false. If it is false before, its negation will be true. And don't forget, like I've said, your negation, you can write it as P bar. You understand now? You can have something of this nature anyhow. So that is your negation. And another thing I want you to notice that when you are finding notes, the negation of a proposition will give you that proposition back. I hope you understand now. Okay, now I have the negation of P now. Let me find the negation of negation of P. And let's see what we have. Or let me simply, yeah, don't mind this. Okay, it means we have to find the negation of this column, F and T. What will be the negation of F? Negation of F will be T. What is the negation of true? Negation of true will be false. I hope you understand now, as you can see. So you will see that this has given rise to what again? So to P. It means negation of a statement is that statement. I hope you understand now. That's for negation. I'm still going to explain. When you have two statements, when you want to find negation of two statements, when I'm proving the Morgan's theorem. So if that is cleared, and we now understand what negation mean, that is negation of a true statement is going to be false, and negation of a false statement is going to be true. Let us move to conjunction. Recall conjunction is what? You are going to be using connective and. I hope you understand now. And don't forget, I said it's also the same thing as this. And before you can use conjunction, you must have how many statements? Two or more. Okay, now let's say suppose we have two statements, P and Q. I hope you understand now. You know the possible truth value of P is true and false. So the possible value of Q is also true and false. Then the combination of all of them will be 4. I hope you understand. Just like when you are what? So when you are tossing a die, when you have two now, maybe when you have true, false, I can have what? True, true. I can also have true, false. I hope you understand now. So I can have what? False, true. Then I can have false, false. I hope you understand now. It means because since they have two statements, then the possible combination of the truth value is what? 2 raised to power 2, which is equal to 4. Likewise, when you have three statements, the possible combination you can have is what? 2 raised to power 3, which is 8. When you have 4, the possible combination you can have is 2 raised to power 4, which is 16. I hope you understand now. So it means if I want to construct a truth table for what? For these two combination and using conjunction, it is not difficult to do. Just let us draw our, then you have what? True. The first one, let's say this is statement P. Let me change my marker. So let's say this is statement P. Okay. And this is statement Q. So if you have two of them like this, what you are going to do is to what? You have true, like what I've just written here. True, true, false, false. That's the possible value you can have. The possible you can have two what? Two true. Since you have two combination, check what I've done here. Then this will now be what? True, false, true, false. I'm going to explain why you have 3 for you. Don't worry. Okay, now let us now find the what? Conjunction P and Q. It is not difficult to do. Listen, let me just use an example so that you get it correctly. If I have my proposition P to be 1 plus 1, you understand now, is equal to 2. It is a proposition, right? And it is true. And the first of this proposition will be what? Let me write it in red. Maybe when I say 1 plus 1 is equal to 7. That is wrong. 1 plus 2 is equal to 7. So that is false. It's also a proposition P. Okay, now let me have another proposition Q. Proposition Q, if I have 2 plus 1 is equal to 3, that is true. I hope you understand now. If I have another proposition Q which is assumed to be false, Maybe I have 1 plus 10 is equal to 19. That is false. I hope we see that. Okay, now let us now take it together. When I have true statement and truth statement, true and true, true and true, if I say 1 plus 1 is equal to 2 and 2 plus 1 is equal to 3, it is true. I hope you understand now. It is true. So then I have true here. Oh, I hope you understand now. Okay, now let me now put true statement. 1 plus 1 is equal to 2 and first one. So, and 1 plus 10 is equal to 19. 1 plus 1 is equal to 2. That is true. 1 plus 10 is equal to 19. That is false. If I combine them together, can I say, okay, now everybody listen, 1 plus 1 is equal to 2 and 1 plus 10 is equal to 19. Is that statement true? No, it is false. The moment you put and, so it means this is false. Okay, now, what if I say 1 plus 2 is equal to 7? We know it is false. 2 plus 1 is equal to 3. It is equal to what? It is also true. Okay, what if I say 1 plus 2 is equal to 7 and 2 plus 1 is equal to 3? Is the statement true? It is false. I hope you understand now. So, the moment you put and, it means before, when you are using your conjunction, if at least one of the statement is false, then your truth value will be false. I hope you understand now. So it means, okay, now what of false and false? When I say 1 plus 2 is equal to 7 and 2 plus 3 is equal to 1 plus 10 is equal to 19. That is false, totally false. I hope you understand. And that's conjunction. Now please take note of it. It means true statement is going to be, when you are taking conjunction, two statements are going to be true only if both of them are true. I hope you understand now. So, and they are going to be false if at least one of them is false. That's what we have here. That's what this guy is saying. So that is, when you have true and false, true and true will be true, then the rest is going to be false. I hope you understand that. Please take note of that. So if that is cleared, let me quickly give you an example to back it up so that you see what I mean. Example. So, example, if I ask you to construct, a truth table for this proposition. Example, construct the truth table of the proposition. What is our proposition? We have negation of what? P conjunction, or you say and negation of Q. Okay, now it is not difficult to do. Logic is very interesting and simple. What you are going to do if you have something of this nature, check how many propositions were you given. You were given two propositions, right? P and Q. Then the possible, a truth value you can have is what? It is 4. That is 2 raised to power 2. Then you have your what? P. Then you have your what? You have your Q. Okay, now let us draw the table. Something of this nature. Something of this nature. Recall what you are going to do is what? So with what I've shown up there is to do what? So this is going to give me what? Let me just change my marker so that it makes more sense. So this is going to be what? True, true, false, false. Like I've written up. Okay, then your Q will be what? True, false, true, false. I explain how. So I explain how. Okay, now we want to construct this table. Negation of P conjunction negation of Q. You can use your order of operation too. You start from bracket. It means we have to start from P and negation of Q. But even before we write P and negation of Q, I have to know because I know P, I know Q, but I don't know negation Q yet. I have to find negation of Q. Then you have negation of Q. So what will be your negation of Q? So your negation of Q, it means you negate Q. And don't forget, if a truth value of a statement is true, then its negation will be false. Okay, now what will now be negation of T? That is false. Negation of false, that is true. Negation of true, that is false. Negation of false, that is true. I hope you understand now. Then we can now marry P and negation what? Q together now. Okay, let me just highlight what we are going to do now. We want to marry this guy as well as this guy. And we want to use and. And don't forget your conjunction and. That is, when you are taking conjunction of two statements, the conjunction of two statements is going to be true only if the two statements are true. Otherwise, the rest will be false. If I were you now, I would just say, okay, now marry them together. True and false, that is false. False and true, that is false. True and false, that is false. False and true, that is false. When only you can only have what? So you can only have what do we call it? So, oh, I made a mistake. Oh. Let us check it again. We are to take P and negation Q. True and false, that is false. True and true, this should be true. Sorry, let me clean it. This should be true. I hope you understand that. That should be true. Recall, you can only have true when the two statements are what? When the true statements are true. I hope you understand now. Then we have false, 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 true, true. Okay, now. Then you do the last one. Now that I know the one inside the bracket, then you can find the next one. So, and the next one is going to give you what? That is negation, negation P and negation Q. That is, you have find negation of this guy. What will be the negation of this guy? What is negation of F? T. Negation of T, F. Negation of F, T. Negation of F, T. I hope you understand now. Then you can now conclude that. So this is your what? This is the truth value of that. So this is truth table of that. I hope you understand now. Okay, let's say if you have three statements. What if you have three statements? What are you going to do? Maybe the question, I'm going to explain the order for you so you don't need to stress yourself. Let's say the statement show that, we ask to show that A conjunction B conjunction C is equal to what? So A conjunction B conjunction C. We call this an associative property. I'm going to explain very well when I get to some properties of logical reasoning. So now we have how many proposition? We have three proposition, and since you have three proposition, it means the possible combination of truth value we can have is what? 2 raised power 3. That is 8. But I've not derived that for you before. I can also do that for you. It's just like tossing 3 coins together. You know the possible value is 2 raised power 3. It means we have what? True, false. Then I can have what? True, 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 false. Then I can also have what? False, true, false, false. Okay, now, what of the third combination? I can have what? True, true, true. Just add true to this and also add false. I can also have true, true, false. I hope you understand now. What of this guy? You know you have TF, just write TF, TF. Then the first one put T, the second one put false. And for this one, just write FT, the first one put true, the second one what? Put false. I hope you understand now. And the last one we have false, 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 false. But the first one you put true, the second one you put false. I hope you understand now. So if you check this guy very well, you will see that I have true, 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 false, false in the first what? In the first pair, it means I'm going to have first now A, B, C. But let me give more space. I have A, B, C. So let me just draw it. I have A, B, C. Let me make the line to be more perfect. or more straight. I hope you understand. Yeah, we might need it up to that place. So if you check the possible pairs I have now, you can see that for the first A now, that is A, I can have 4 true, 4 false. The second one, 2 true, 2 false, true, 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 false. I hope you understand now. So then the third one, you take them in what? In 1, 1. So you take them in 1, 1. Okay, this is what I'm trying to say. And this one is going to take it 4, 4. True, 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 true. That is 4, right? Then you have false, 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 false. Uh-huh. Then the second one, you take them in 2, 2. True, true, false, false, true, true, false, false. I hope you understand now. And lastly, you have take them one by one. True, false, true, false, true, false, true, false. You can see it is very simple. And what were we asked to show? The question asks us to show that, let me just write it so that we get it clearer. So the question asks us to show that, so that is A conjunction B conjunction C is equal to what? A conjunction B conjunction C. You can do this in 2 ways. The first is to just find this and compare them together. You can draw a truth table for the first one, so and draw a truth table for the second one and then combine them together. So or you can just do them together in the same table anyhow. So it means what we need here is what? Well, first of all, we need A and B. We need A and B. I hope you understand now. Okay, A and B, then you have true, true. True, true will give me true. Remember, you can only have true when both of them are true. True, true, this is also true. True, false, false, true, false, 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 true, false, false, true, false, 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 false. Can you see now? I hope you can see. That is not difficult. So that is not difficult. Okay, now if you check it very well, you will see that if I want to do it in another way, okay, listen. I think this is the, you can do it this way again. Now that I know A conjunction B, let me now conjunct it with C. Let me have A conjunction B conjunction C. Then it means you are going to marry this colon with this what? With this colon. Then I'm going to have, don't forget this is the first statement now. True, true. So true, true will give me what? True. True, false. That is, sorry. True, true, false. False. False, true. False. 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 You remember it can only be true if two of them are true. False. 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 I hope you understand now. Okay, now let us continue. Let us continue. Okay, now it means we've shown the left hand side. What of the right hand side? It means let me find my B and C. Then if I know the B and C, then I can find A and B and C. But let me find my B and C first. So B and C. Okay, now what will be your B and C? The same way. The same way. B and C, it can only be true if two of them are true. Then you have true, true, true. Is that okay? We are finding B as your true, false. false, false true, false, false false, false true true, true true false, false false true, false false false, false. I hope you understand. Then lastly we can have A and B and C. So A and B and C, then you can now check whether they are correct. Okay, now let us show that. So you are marrying it with what? With A, this with this. Then you have, let me just change, this A and what? And this guy. Okay, now let us check it. True and true, that is true, true false, false, true false, false, true false, false, false true, false, false false, false, false false, false, false false, false. Remember, you can only have true if both of them are true. Okay, now can you now compare the two of them together now? The first one being this, we asked to prove that this guy and this guy are equal. Can you see now? If you combine them, compare them together, you will see that they are equal. So then you can now conclude adequately that therefore, so A and B and C is equal to what? A and B and C. So we call this what? Associative property. So we call this associative property. So that's that on conjunction. So, but if you don't want to stress, another way you can do is to construct the truth table of this. Construct the truth table of this and combine their answer together, and you will see you are going to arrive at the same result. Okay, now if that is clear, let us move to another connective disjunctions. 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 So recall for disjunction, it is connective or, right? Or the cup-like shapes. I hope you understand now. It means before you use conjunction again, you must have had what? Two propositions. And don't forget, when you have two propositions, eh, the possible truth value you can have is 2 raised power 2, which is 4, like I've explained before. Then that will not waste much of our time. Then you have your what? You have your P, you have your Q, and don't forget, this guy will now be what? You have something of this nature, you have something of this nature, then we have P or Q. So, but before we go, let me use the same example we use in conjunction. Let's say I have proposition P. Let's say I have proposition P to be what? So, maybe proposition B is 1 plus 1 is equal to 2. You know that is true. Then proposition Q is 1 plus 3 is equal to 9. You know this is false, right? So, yeah, just let us think of it. Recall, I said you are going to have what? True, true, false, false. Go and check how we form the combination. Very well. True, false, true, false. Okay, now for all, if I have true statement, for example, now this statement is true, or maybe I should not even use what? I should not even use P and Q so that it won't confuse us. Let us just have true statement. True statement, one of them is true and one of them is false. I hope you understand now. So, if I have true, true, I can say 1 plus 1 is equal to 2, Or let me have another true statement. So then maybe, yeah, to make it more clearer, let me have another maybe 3 plus 1 is equal to 4. Yeah, both of them are true. Let me write the first one. 2 plus 5 is equal to 19. That is false. 1 minus 2 is equal to 7. That is also false. Okay, now, true, true. If I say 1 plus 2 or 2 plus 5, is 1 plus 1 is equal to 2 or 2 plus 5 is equal to 19. That is true because you are using or you understand that, or that is either one of them. So 1 plus 1 is equal to 2 or 2 plus 5 is equal to 19. Yeah, that is going to be true. I hope you understand now. Okay, now what if you say true and false? Now, sorry. The first one should be 1 plus 1 is equal to 2 or 3 plus 1 is equal to 4. Yes, it is true because you are using or. Okay, Nigeria, let me still use another example. Nigeria is in Africa, Lagos is in Nigeria. Yes, yes, it is true. Okay, let's say if now have one combination, one true statement and one false statement, 1 plus 1 is equal to 2 or 2 plus 5 is equal to 19. Yes, it is true because you are using or, but if you are using and, it will be false. I hope you understand, and this is also going to be true. Okay, now if I take one false or one true, 2 plus 5 is equal to 19 or 3 plus 1 is equal to 4. Yes, it is also true. Just like when you say Nigeria is in Africa, or Lagos is in Ghana. It is, you are saying or, that is either. So it means once one of them is true, then you can say yes, yes, it is true. I hope you understand now. I hope you understand. So, okay, but false and false, if I now say 2 plus 5 is equal to 19 or 1 minus 2 is equal to 7, then that is wrong. That is false. I hope you understand now. It means for disjunction, the only time you can have false, unlike conjunction, the only time you can have false in disjunction is when both of the proposition are false. I hope you understand now. But for conjunction, the only time you can have true is when both of them are true. Don't mix them together. Just if you want to forget, just use the same example I give to you. I gave to you. I hope you understand now. So that's for disjunction. That is for disjunction. Okay, let me just give you another example there as well. Example. The question asks us to do what? Construct the truth table of the propositions, negation of A, that is, don't forget your negation, or negation of B. I hope you understand now. So, though we are still going to, because this is the same thing as negation of, but let me get there. When we get to De Morgan's theory, you are going to get it very well because what I wrote here is the same thing as what. In fact, we can show it. Let's say the question asks us to show that this is equal to this. I hope you understand that. So this is what the Morgan's law. But we want to find this, but at the end of the day, I want to show this. You see, we are going to get the same result. Okay, now let us start. We have two propositions. And since we have two propositions, then we must have what four possible combination of the truth values. So we can have four possible combination of the truth value. Okay, now let us draw it. I have my A. Now I can have my A. I will have my B. But since then you can also find your negation A, negation B. Then after that you can find what negation A or negation B. That's what we asked to find. If I were you, just try and do it, break it down first. I hope you understand now. Then you can now draw your line. So you can draw your line. Let me use a straight line so that it will make more sense. It will make it more clearer. Okay, now. Okay, okay, okay. Yeah. And this, recall, we have our truth table is what? We have two combinations. We have two proposition. Then this is going to, if when you have two proposition, you are going to have what? True, true, false, false in the first, true, false, like I've derived it, true, false. This one is negation of A. That is, go to column A. What is negation of? Negation is if it is true before change it to false. If it is false before change it to true. Negation of true will be false. Negation of true will be false. Negation of false will be true. Negation of false will be true. What of negation of B? Oh yeah. So negation of true will be false. Negation of false will be true. Negation of false will be false. Negation of false will be true. I hope you understand. And then we can now marry these two guys together. And this is all. Recall, the only time you can have true when you are using disjunction is when both of them are what? The only time you can have false is when both of them are false. It means false or false is false. I hope you understand now. So then this is true, this is true, this is true. If you've forgotten, please refer to the first example. So that's what we asked to show. That's what we asked to construct. But I told you that this guy, that is the negation of A or negation of B, I told you it is the same thing as what? Uh, negation of A and B. I hope you understand that. We call it it's one of the De Morgan's law. I'm still going to state it, but let us quickly show this. Suppose we are now, we want to find A, negation of A and B. Then you have A and B first. You have A and B. Then after that, you can have negation of A and B. You have to break it first, break it down first, since that's what we have. So, okay, you have something of this nature. You have something of that nature. It is very long. That is strange. What is happening? The marker is getting slower. Perhaps it is tired. Okay, now don't forget, since you have two proposition, you have what? Two possible. You have four possible truth value, and this is going to be what? True, 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 false, false, true, false, true, false. I hope you understand now. So what will now be A and B? Don't forget, when you are using conjunction, that is, conjunction of two proposition can only be true if two of the statement are true. Then true, true will be true. Then the rest will be what? False, false, false. Then we have to find the negation of this guy, negation of A and B. That will be false, true, true, true. I hope you understand now. So false, true, true. False, true, true. What is wrong? So false, true, true. So if you check it very well, you will see they are the same with what we had the other time. They are the same with what we had the other time. We have false, true, true, true. Let us check this guy also. So can you see it is false, true, true, true as well? So it means the Morgan's theorem is what? Is satisfied. So that is for disjunction. Recall, for conjunction, two proposition can only be true if both of the proposition are true, otherwise they are false. But for disjunction, true proposition can only be false if both of them are false, otherwise they are what? They are true. So Let us move to conditional statements now. Conditional statement. Don't forget, conditional statement is what? It's the same thing as implication. So the same thing as implication or what? We also use if a statement, then another statement. So it's also the same thing as if a statement, then another statement, then another statement. I hope you understand now. So, okay, now if that is cleared, let me use an example so that you understand it very well. You know, this is an implication. Let's say I have a statement P which says if you pass, and statement Q is I'm going to give you $10. Sorry, this is strange. I'm going to give you I'm going to give $10. I hope you understand now. So that is if then. You know, if you want to marry P and Q together now, so let us construct the table so that you understand it very well. Let's say I have P, so you have PQ like this. Don't forget, this is going to be true, true, false, false, true, false, true, false. What this is implying is this, look up. You know, now it is true, true. If you pass, I'm going to give you $10. I hope you understand now. You know, at the end of the statement, this is my promise. You know, later I fulfill my promise. Then it is true. I hope you understand now. So then it is true. But if you pass and I fail to give you $10, you know I didn't fulfill my promise. Then my condition, that the condition is false, because I said if you pass, I'm going to give you what? I'm going to give you $10. But now you pass, I didn't give you $10. Then this is going to be what? This is going to be false. So, but the second one is okay. Let me do this one now. So if you don't pass and I don't give you $10, that's the first one. If you don't pass and I don't give you $10, then there is nothing about it. The statement is still true. But even if you pass, if you don't pass and I still give you $10, it doesn't mean I didn't fulfill my promise. That is also true. I hope you understand now. So it means all of them is going to be true except when you have the fact that you pass and I didn't give you your dollar. So that is a proposition, two proposition. A proposition implies another. When you have this implication, if then all of them is going to be true except when the first one is true and the second one is false. I hope you understand now. So please, I want you to take note of it very well. So let me just give you an example. Let's say I have you have copy and complete this truth table, copy and complete below truth table. Then I have P, I have Q, I have P, then Q, I have Q, then P, then I have P. I think it is bigger. Let me ensure I have it in Q, then P, Then I have P, then Q, and Q, then P. I hope you understand now. So let me draw it very well. Perhaps using a straight line. Uh-huh. Okay, now let us proceed. But before we go, recall when you are using conjunction, that is and, it means true statement is going to be true if both of them are true, and for disjunction, so they are going to be false if both statements are false, and for implication, you can only have false when the first is true and the second is false. Okay, now let us now do it. Don't forget, what are we going to have now? So, recall this is going to be what? True, true, false, false, true, false, true, false. Okay, what is P implies Q? True, true. If you pass, I give you dollar, then I keep my promise. If you pass, I don't give you dollar, then I didn't keep my promise. That is false. If you don't pass and I still give you dollar, that does not mean, I can just give you pay. Well, you try. So that is also true. So when if you fail and I didn't give you, then that is also true. I hope you understand now. Okay, what of Q and P? True, true. Recall, don't forget it is true. False, true. It is true. True, false. That is false. Because you pass and I didn't give you money, that is false. False, false. That is true. Uh, that is also what? Sorry. So that is, I think I made a mistake here. So I think this statement is also true. What am I saying? Yeah, I think I didn't make any mistake. Okay, now let us now combine the two together. Just note that it is only going to be false when you indeed pass and I didn't give you your money. Okay, now let us now marry this together and recall you can only have when you are doing conjunction, you can only have true when both of them are true. True, true, this is true. Then this is false, and this is true. So you have true, false, false, true. I hope you understand now. So you have true, false, false, true. So that is that. And let us do the last one. So the last one here is biconditional. Biconditional or what? Or equivalence of a statement. Biconditional or equivalence of a statement. Recall I told you it is also the same thing as what? If and only if. And don't forget, for if and only if, what I said then is that when you have true proposition, that is if P, then Q, and what? Conversely, if Q, then what? Then P. I hope you understand that. That is, if you pass, I'm going to give you $10. If I give you $10, you must pass. I hope you understand now. So, okay, now let us do it. Let us construct the truth table for that as well and see what we are going to have. Because you have P, we have Q, then now we have P, if and only if. So, that is, you have the arrow on the truth side. So, then you have P, Q, true, true, false, false, true, false, true, false. I hope you understand now. If you pass, I'm going to give you dollar. If I give you dollar, you must pass. Then this is true. I hope you understand now. Okay, now, if you pass, I'm not going to give you dollar. I hope you understand now. If you don't pass, I give you dollar. That is false. I hope you understand. That is if and only if. If P, then Q, and if Q, then P. Okay, now if you fail, I'm going to give you dollar. If you pass, I'm not going to give you dollar. So that is false. I hope you understand now. So then if you fail, I'm not going to give you dollar. If I don't give you dollar, you fail. That is true. So it means, yeah, you can only have true when both of them are true. Then you have false when both of them are false. I hope you understand now. So please, you have to take note of all of them. I hope you understand. You have to take note of all of them. So, and for what I've done so far, so let me just revise some of them. I think before I do the revision, so let me just summarize what we've done so far so that you don't confuse them with each other. That is when you have your P, when you have your Q. So we will know negation is trivial. Then your P and Q, let us find P or Q. P implies Q. And lastly, P if and only if Q. Okay, now this is true, true, false, false, right? So true, false, true, false. Then P and Q, it is only going to be true when both of them are true, other will be false. P or Q, it is only going to be false when both of them are false, other is going to be what? Are going to be true. P then Q, it's going to be false only when first is true and the second is false. The rest is are going to be true. I hope you understand now. And P implies Q is going to be true when both Q and false, and when both are what? Are what? Are false. So the rest is going to be what? False, false. So that is that. So that is that. I hope you understand now. So if that is cleared, then I want to employ you to what? To go through of them. I'm going to continue in the next video. So if you are really serious about learning mathematics from scratch, then you've come to the right place. Why not kindly subscribe, watch, like, share to your colleagues so that they can benefit too. I will see you in the next video.